Hello and welcome to a new lecture. Infrastructure as Code (IaC) is a powerful approach to managing and provisioning computing infrastructure through machine-readable configuration files, rather than physical hardware or manual configuration. It allows for greater scalability, consistency, and speed when setting up environments, making it a cornerstone of modern DevOps practices. IaC automates the process of setting up infrastructure, allowing teams to manage their IT infrastructure as they would application code, resulting in significant improvements in deployment speed, consistency, and repeatability. Infrastructure as Code (IaC) refers to the practice of managing IT infrastructure, including networks, virtual machines, load balancers, and connection topologies, through code instead of manual processes. In this approach, configuration files define how the infrastructure should be built and maintained. These files are treated like code, enabling organizations to track changes, manage versions, and easily replicate environments. By using IaC, teams can create, update, and scale environments consistently and repeatably across different development, testing, and production environments. The adoption of infrastructure as code offers several key benefits. One of the most significant advantages is consistency. Since the infrastructure is managed through code, each environment is provisioned in the same way, reducing the likelihood of human errors that can arise from manual configuration. Scalability is another major benefit, as IaC allows for the rapid provisioning of resources across different environments, making it easier to manage large-scale infrastructure. Additionally, version control is a key feature of IaC. Storing configuration files in systems like Git enables teams to track changes and easily roll back to previous versions when needed. The increased speed and efficiency provided by automation allows teams to deploy infrastructure faster, which in turn accelerates development and testing cycles. Lastly, IaC improves disaster recovery by enabling organizations to recreate entire environments quickly using predefined code, enhancing resilience against downtime and data loss. Several popular tools are available for implementing infrastructure as code. Terraform, an open-source tool by HashiCorp, is widely used and supports multiple cloud providers, allowing users to define infrastructure in a declarative language, HCL. AWS CloudFormation is another powerful tool that allows users to define and provision AWS resources using JSON or YAML templates. Ansible is an open-source automation tool that focuses on simplicity and agentless infrastructure management, using YAML for configuration. Puppet and Chef are also popular options for automating server configuration and management, each offering different approaches to writing infrastructure code. Lastly, Azure Resource Manager, ARM templates, are used to define and manage infrastructure on Microsoft Azure using JSON templates. To successfully adopt infrastructure as code, organizations must follow strategic best practices. One important strategy is to use declarative configuration, which allows teams to define the desired state of their infrastructure without specifying the exact steps needed to achieve it. Tools like Terraform and CloudFormation use this approach, making it easier to manage infrastructure changes. Another key practice is to version control infrastructure by storing configuration files in systems like Git, which ensures that all changes are tracked and can be audited. Modularization of infrastructure is another important strategy, which involves breaking infrastructure into reusable components, making it easier to manage and scale. Automated testing of infrastructure changes is also critical. Just as application code is tested, infrastructure changes should be validated to ensure that deployments are correct. Integrating IaC with CI/CD pipelines allows for automated testing and deployment of infrastructure, streamlining the development lifecycle. Additionally, organizations should implement role-based access control (RBAC) to ensure that only authorized personnel can make infrastructure changes, enhancing security. Lastly, organizations should implement drift detection to identify when actual infrastructure configurations differ from the code, ensuring consistency between environments. Despite the many benefits of IaC, there are some challenges associated with its adoption. Complexity can increase as infrastructure scales, making it essential to plan and organize configuration files effectively. Security risks are also a concern if configuration files are not properly secured, as they may contain sensitive information like access keys or credentials. Learning curve is another challenge, as both development and operations teams need to become proficient with new tools and practices. Lastly, if infrastructure is over-provisioned without proper governance, it can lead to unexpected cost overruns in cloud environments. IaC plays a crucial role in cloud-native environments, where resources are dynamic and need to be managed at scale. For example, Kubernetes, a widely adopted container orchestration platform, integrates with IaC tools like Helm, Kustomize, and Terraform to automate the provisioning and management of clusters, services, and applications. In these environments, infrastructure components such as networking, load balancers, and persistent storage can be treated as code, ensuring consistent and reliable deployments. Infrastructure as code is an essential practice for any modern organization looking to efficiently manage its IT infrastructure. By automating the provisioning and configuration of infrastructure, IaC reduces errors, increases deployment speed, and provides a consistent way to manage resources. When implemented with a clear strategy and the right tools, IaC enhances agility, security, and operational efficiency, making it a fundamental component of modern IT and DevOps practices. I hope that was clear for you. See you next.